So the whole function of the excretory system is to maintain homeostasis, which basically means to maintain balance of blood pressure, pH, osmolarity, and remove the nitrogenous waste from the body. Typically, the kidney pathway will go, stuff will come from the blood to the glomerulus and Bowman's capsule, where high pressure will get all the basically nitrogenous waste and water through the pores, and any of the good stuff will leave through the vasa recta and then renal vein. Um, in the kidney, you've got two types of muscles. Well, sorry, this actually should be the bladder. Internal are involuntary, smooth muscles. External are voluntary skeletal muscles. We remember is internal involuntary, the INs. Kidneys will have three processes: filtration, secretion, and reabsorption. Filtration is moving the solutes from the blood to the filtrate at the Bowman's capsule using hydrostatic forces. Secretion is moving the solutes from the blood to the filtrate anywhere else but the uh, Bowman's capsule. And reabsorption is taking the solutes from the filtrate to the blood. This means like, sodium ions, potassium ions. So in the kidney nephron, you have the kidney nephron is a functional unit of um, nephron. The nephron is the functional unit of the kidney. So you got the proximal convoluting tube, descending loop, ascending loop of Henle, and distal convoluted tube. So here we go. This is the diagram right here. So all your stuff will come in here at the Bowman's capsule and glomerulus, and then it'll pass through the proximal convoluted tube. And this is basically where you have reabsorption of a lot of your nutrients. So amino acids, glucose is reabsorbed. Usually these don't even pass through because they're too big. Salts are reabsorbed, and then hunk is dumped, which is H plus, urea, NH3, and K plus. In the descending loop of Henle, you've got permeability to water, so which means osmosis out, meaning water will leave through the vasa recta. The vasa recta sends all the good stuff back to the bloodstream. Ascending loop of Henle, you've permeable to salts. As you go up the tube, salts leave. And then in the distal convoluted tube, you've got reabsorbing of water because the water will follow the salts that were reabsorbed. Aldosterone works at the distal convoluted tube. Aldosterone promotes Na plus reabsorption, and water follows the sodium ions to increase the concentration of urine because it's moles divided by liters of solvent, and liters will decrease. In the collecting tube, aldosterone and vasopressin will work on it. Something I want to go over here is the two hormones. You've got aldosterone, which works on the distal convoluted tube, and ADH and vasopressin. ADH slash vasopressin plus aldosterone works on the collecting duct. The aldosterone increases salt reabsorption, which increases pressure and no osmolarity because no water is being reabsorbed. Antidiuretic hormone or vasopressin will increase blood volume, pressure, and osmolarity because this actually moves the water. Reabsorption of H2O and alcohol inhibits the ADH, which basically you won't have the movement of water and you'll have a lot of water loss. That's why when you drink alcohol, you lose water. Skin is divided in three layers: epidermis, dermis, and hypodermis. And the dermis has a lot of the sensory cells. Merkel is for texture, Meissner is touch, Ruffini is stretch, and Pacinian is vibration. So let me go back here. Yeah, here we go, skin. The stratum basum is a keratinocytes, which is the keratin produced in your cells protection. Langhorns are skin macrophages, and then sensory cells in the dermis. Merkel, deep pressure. Meissner, light touch. Ruffini, stretch. Pacinian, vibration. The Langhorn cells will serve as antigen presenting cells in the skin for the immune system.